Okay, so this is problem 6.5.53, and they ask us to perform the indicated operations and then simplify. And so what we're doing here is we're adding and subtracting, and we have some rational expressions. Okay, so the first thing that you want to do when you're doing these problems is you want to factor the denominators, factor everything as much as you can. So this right here, we can see that this is the difference of squares. So that's going to factor into v minus z and v plus z. Okay, and we need to identify our LCM, but before we do that, we want to actually look at the fact that this z minus v here and the v minus z are actually the same, but they're different by a negative. So what I'm going to do, instead of having to have a separate factor in the LCM to account for each of them, I would rather just take this one and flip it around and have it become like that. In order to do that, I would actually need to multiply the numerator and the denominator by a -1. Now when we multiply by -1 over -1, that's effectively multiplying by a +1, which is why we can do that. Okay, and the reason for multiplying by the -1 down here, when we take that -1 and distribute, it's going to make the z negative and the v positive, which actually gives us v minus z, which is the same now as that factor. Okay, so if I rewrite this, I'm now looking at 1 over the v plus z. I now have a -1 because -1 times the +1 gives us -1. This is now a v minus z factor, and then I have my third fraction here hasn't changed. Okay, so now we're in the position where we can go ahead and identify the LCM of the problem. And, and then once we've identified the LCM, that is our common denominator. So the LCM in this problem is v minus z and v plus z. So remember, what you're doing to identify LCM is you're looking at each factor and how many times it occurs the most in any one factorization. So we have a v minus z factor occurring once here and once there and no times there. So the most it occurs in any of those spots is once. So we need it once in the LCM. The v plus z is occurring once here, no times here, and once here. And the most it occurs in any of those spots is once. So we need it once in the LCM. Okay, so this now is our common denominator, and that's what we want to make our denominators look like. So we have to compare and figure out what's missing. This first fraction here is missing the v minus z, so that's what it's going to get multiplied by, top and bottom. This one's missing the v plus z, and the second one, or third one here, isn't missing anything. Okay, so it's going to look like this. Our first fraction is getting multiplied top and bottom by the v minus z, and you need to put parentheses around it because we're multiplying a quantity there. The second fraction is getting multiplied by v plus z, top and bottom, and then the third fraction just comes along and nothing's being done to it. Okay, so at this point we have a common denominator, so we can bring our numerators together, and what we're looking at is v minus z minus the whole v plus z. So this is -1 times this. We're going to need to remember to distribute the negative there, and then we have a -2v, and this is all over the common denominator of v minus z and v plus z. Okay, and at this point what we want to do is simplify the numerator. So I need to take this negative and distribute it through. So this is going to be v minus z, that's this v minus z, and then we have a minus v and a minus z. So that's taking the negative and distributing through. So negative v, -1 times v is negative v, and -1 times z is the negative z. And then we have -2v, and this is all over LCM. Okay, and at this point, we would want to just simplify in the numerator. So let me write down what we have here. V Okay, so if we simplify in the numerator, we're just collecting like terms. So we have a v and a negative v. So those actually cancel. So we're left with just a negative 2v. And then we have a negative z and a negative z. So that's a negative 2z. And then this is all over v minus z and v plus z. Now, when you get to this point, you're basically very close to being done, and you just need to see if there's anything that will factor in the numerator, and because there's a potential that you could have a common factor with something in the bottom and then it could cancel. So I see in the numerator that they have a greatest common factor of a negative 2. So when I pull out that negative 2, I'm going to be left with a v minus z factor, which is the same as one of the factors in the bottom. So we will cancel one of those factors, and we're left with a negative 2 over v plus z in this problem.